Okay, guys, so welcome back. What's up, everyone? Yeah, basically today we kind of like trying to finish up the app we left behind. The last time it's actually almost 7 days right now, and we haven't been able to update it yet. Since we actually run into some issues from the last time we were trying to code the app and build it up. Yeah, finally was able to get some resources to actually get it to work. That was basically from ChatGPT. And that was actually funny on how it was able to actually help me with the code. Unfortunately, ChatGPT is done. Where I wanted to use it to show you guys how I actually was able to use it to solve the issues, the coding issues, but it's actually done. But I'm going to show you some images I actually was able to capture on the answers that ChatGPT gave to me. It was awesome. Was great trying using it to get the solutions to our problem. Yeah. So this is one of the questions and stuff like that. So just go ahead and open this. Yeah, so I was actually playing around with it, trying to see if we can actually use it to solve our issues, because the issue we were having was being able to broadcast our socket messages. So basically when someone sends a message, everybody that's listening, everyone that's using our app should be able to get messages. So that's basically the issue we are having. We are unable to get that to work because we actually implemented the backend with that. Unlike Node.js, it is actually easy to implement with Node.js backend and then use Flutter for the front end. I've done something like that and it worked. You can actually easily do that by using socket IO. I will show you that. I think I will do another separate video on using Node.js and Node.js socket.io and Flutter socket.io implementation. So basically I'm talking about socket.io. Yeah, so this for the Node.js. You can actually use this, and also it has Flutter implementation. You can actually utilize the Flutter implementation too. I think we should be heading to pubdev. Pubdev have something called socket.io. There you go. So it's called socket.io client. So this is what you'll be using in the Flutter front end, and on the back end with Node.js, you just use this on back end with Node.js. So I've used it in an app, and I will probably do a video on how to actually implement this, and it's gonna be fun. Yeah, with that being said, so that was the issue we are having because we are using that backend, and you guys already know these are that server we are using. So we implemented a socket with our that server. So these are that server, and trying to get this communication being when someone sends a message, another person on the other receiving end should be able to get the same message and also send a message back, and the other person should be able to get a message back also. Yeah, so that was the issue, and I actually went to ChatGPT. On ChatGPT, I was actually asking the question. Right, let's start with the first one. Should be from 10. I think that should be question number 10. Yeah, so this is one of the questions: how to output a socket server stream when all data event is complete using Flutter that. And you guys are going to see how. So this was one of the answer is suggested. Because I'm not using stream builder in my app, so this one I didn't make use of this solution, but it's actually good if you are using stream builder to listen for changes from the socket itself. You can use that solution. The next one, okay, now this I just wanted to use the ChatGPT itself, but the server is done, and we will not be able to use it in this stream. Maybe next time. So let's actually take a look here. Okay, let's start with 4. So yeah, so this actually how to accumulate incoming buffer data and concatenate it when socket server is done. So basically the question here is basically how to actually one of the issues that, well, let's say you are trying to send images or audio data or some stuff like that, back to the back end, it's actually always chunks the data into, it kind of sends the data into different chunks, chunks of buffer. So what we are trying to do, we want to be able to get all the streams or all the data before we can actually be able to add it together or display it as an image, or add it together and display it as an audio to be listened to. So that's why I was asking this question, because actually we had that issue too, and this is actually the answer. Let's see the next one. Yeah, still the same question, at putting socket, buffer and all those stuff, yeah, but which actually was able to get it to work and some stuff like that. And ChatGPT is actually working, so looks like we just have to go ahead and start coding this up. So if you take a look at the server, I'm going to put it back on, but right now the server is not running. Even the front end, although the front end is running, but the server is not running, but we have to put it back on. So this is our server right here. And what we did, if you could remember, the last time we are using WebSocket channel for communicating with our server using WebSocket, and over here I commented out the code for that. I no longer use this WebSocket, so WebSocket I will not be using that, and I actually moved it to use socket, server socket from Flutter itself. So Flutter has this implementation or class, abstract class called socket server, which you can actually get from that.io right here. So once you import that.io, it will just give you access to the server.socket, which you can actually use to build the web socket implementation and communication stuff like that. And we are passing an IP address, which is basically in this case is our local host, and then we are passing a port to it. A port it actually listens to for any communication. And we have handle connection function here. Basically what this does is to actually listen to whenever someone makes a connection to our server, and then this function will be called, and when this function is called, it will just add that particular user to a list of clients, basically a list of listeners or a list of connections that wants to talk with our socket server. And this is actually where we created the list down below here. So we have an array called chat client. Basically anybody that wants to chat with us is called a chat client, and we added inside this list. So in this case we can actually have more than 2, 10, or depending on how many we can actually accommodate in here. So yeah, that's basically it for the back end. And and also we have this class. Most of this is being, I got this solution from article written by someone. I'm trying to see if I can actually find the article. So it's actually very helpful. And the good thing about the article is basically it kind of shows you how to work with networking in Flutter, and kind of like a base level of working with Flutter networks, or basically networking with Flutter. Yeah, it's called James Locum. I don't know if I got the name correct, but basically it's the article where I used to get the solution to solve our problem. Back to the server right here. Yeah, we have a class called chat client, and inside the class it has these variables called socket string, which is an address of that particular client, and again the ports whereby the users kind of listening to. So we have the socket server address, the remote address, and also the remote port. And inside the constructor right here we are calling socket.listen, and also message handler whenever a message is being sent through that particular client, and this is what we're going to handle the message for us. And we have the error, and we have the finish handler, and we have a write function that helps us to write message back to the clients and some stuff like that. So yeah, that's basically it. We have this function called distribute message. To explain what this function is doing, this distribute message, basically what it does is to go through all the clients that we have right here, and then see which of the clients, so, and basically send a broadcast the message to all the client that's listening except the client that sent that particular message. So basically what I'm trying to say is that when I send a message, I will not be able to receive back the message I sent, but other people that's actually listening, or other people that I'm actually chatting with on the app will be able to receive the message, except me that sent the message, so I won't be able to receive the message. And likewise, if anybody within the chat group sends a message, they won't be able to receive back the message is sent, but every other person can actually get that same message. That's basically what this function is doing. Basically, it loops through the client and see if client is not equals to the client that actually sent the message, then go ahead and broadcast or write to the clients that are actually listening at the moment. So that's basically what this function is doing. And then whenever the client kind of disconnects, go ahead and remove the client from this array of clients. So that's basically the main features we added here. I don't think there's any other stuff I added that you guys haven't seen already from the previous stream that we did. So if you are joining us for the first time, go ahead and check out the first two streams that we did. You can actually get a quick understanding of what we're actually doing here and how this works together. So yeah, I think we actually explained what the new changes we added to the backend. Let's go ahead and start the backend and start building the front end with it. So I'll go ahead and run. So just run the backend from here. Just tap on this from your VS Code and start running the backend. You can actually see now the backend is up and running and is actually listening to port 8080, and then our WebSocket is actually listening to port 4567. So that's it. Next stuff, I'll go ahead and minimize this. The server is running, but I'll just minimize the server and then open up our tool simulator so we can actually take a look and see what we are doing. Then the next stuff we could actually do is to restart this. So nothing is actually happening in this case. So let's go ahead and fix some problems we have. So we are still using WebSocket channel in this case, but it won't actually be able to communicate with our backend because our backend is not using WebSockets. We are using just sockets, main socket communication from Flutter. So we need to remove this particular code. We don't need it anymore. So basically go ahead and delete this from your front end. And also I'll actually upload this to my GitHub, so you guys should actually take a look on it. If you aren't following along, you can get the code from the GitHub also and just work along with it. But that will be when we are done with this. So I'll go ahead and delete this entirely from here. I don't need it anymore. We don't even need it. We still have our dummy list of messages that we are just using to display stuff here. Next, within the connect server, we need to use our socket itself to communicate. So let's go ahead and do that. So inside here, I'm going to create something called socket. Like I said, this is coming from that itself. Socket the implement stream of type unit8 list, and also with iOS input output sync and some stuff like that. So here we have this socket. We're just going to socket.connect, or you can use start connect, but in this case I'm going to just use connect, and the host is going to be localhost. Yeah, we'll just use localhost in this case. Localhost, and the port we want to listen to, we just give it any port, but we still have to listen to the same port that our backend is listening to, which is basically 4567. So that's the port we give to it. And then since this is actually a future, so we have to either await for it to finish or just use the then condition, basically the same stuff. When this completes, when the feature completes, any other code that's in here will start running. So that's why I'm using the then. And inside the then, the value is going to return is basically, I'm going to call that value to be of type socket, which is actually the type, and the name is going to be called sock. And yeah, it's going to cap this to close. And within in here, I'm going to say socket is equals to sock, and we are getting this socket because I created a variable here called socket, and we are just initializing it to it because we, if you could remember, we actually marked it to be late initial, right? So that's why I'm just initializing it back to it. I can't believe we actually waited for 7 days to actually do the second stream. I don't think I've taken this long in any of the stuff we have been doing so far, but I don't know why. But yeah, actually took me quite some time to actually grab most of the stuff here and be able to get stuff to work before I can be able to stream it with you guys. So yeah, what we are doing is basically we are listening to the socket stream that has been returned over here. We kind of like initialize this to this socket we already have, and we're saying socket dot map. So basically we are on the stream, don't map any stream of data that's coming in, and we're going to map it to a type, unit 8 type. So basically it's actually a type of, the type is going to return is a unit 8 unsigned. Basically I call it unit 8, but basically what it means, unsigned integer. So we have unsigned 8, yeah, list, unsigned 8 int 8 list. I'm just trying to rename it so that it won't be the same spelling with the main class we have in Flutter, so it just be a bit different. But we are naming the type of data is going to return, which is basically a unit 8 type, and we are just giving it this variable right here to access it. Basically, I don't know why I'm calling it a unit 8, but basically unsigned integer 8 list. And over here I'm going to say unsigned integer 8 list dot to list, convert it to a list. Once that is done, then I'm going to add another stuff to transform this data. I'm going to say transform, use constant utf8 coder, not encoder but decoder, to decode, because our data will be in form of utf8 utf8 decoder. So there's where we go. And next, basically I'm going to listen when all this have been transformed. So the next step is just to listen to the event that's coming in, and over here in the events it needs 3 functions, one for on data, one for on error, and one for undone, and one for cancel on error. So we need these functions to be added into our socket right here inside the listen function, so that I can actually be able to send us, it will be kind of a callback function, can be able to send out data back when there's a stream of data that's coming in. This function will handle it. Whenever there's an error, this function will handle it, and when the socket is done, or when we disconnect from the socket, or socket disconnects, or the server disconnects from us, or no, when the server disconnects from us, yeah, we get it here. Or basically when we kind of like say or close, whenever we close the socket stream, we should be able to get the information right there in the undone function. And then we have the cancel on error boolean. Basically, if you want this to cancel whenever there's an error, the socket will just basically stop listening and cancel this, but we don't want that. We still want it to continue listening whenever there's an error, so just leave it that way. But I'm going to go ahead and create the other functions that we need. So right below here, I'm going to create another one called data handler. So it's going to be a type void. No, it's going to be over here. So I'm going to say void let's see, void data handler, yeah, since it's gonna accept some data streams that will be coming in, and I'm gonna make it to be asynchronous. And now we can just use this function right in here. Yeah, then we have a comma. So the next function that we're going to use, the next function we're going to add is on error function to handle any error that will be coming in. So just go ahead and create that function, but I'll just copy it over. And also the last function, which is the done function, just copy them over and then go ahead and explain to you guys what is going on here. So we have these two functions. Basically go ahead and remove this, leave the log statement. Then we have the error handler. Whenever there's an error, go ahead and log the error for us. For now, we just want to log out the errors and some stuff like that. Yeah, we don't want to do any other stuff. So we need to add these two functions right in here. So I'm going to say comma. The next one is basically on error. So error function name again, error handler. Just copy the name, paste it right in here, then comma. Just add a comma to it and then add some other stuff. But this requires us to have this on error, then add this function to it. The next one will be undone. Then we can go ahead and add the undone function. Basically we call it done handler right in there. Then after that, go ahead and close this off. Let's see if there's any other stuff I'm missing. So we have, yeah, so the cancel on error, so we're gonna set this to false. We don't want it to cancel on error. Then I'm gonna add a cache. So whenever there's error from the socket connection, so we will just want to cache those errors. So I'm gonna go ahead and say dot cache on this endpoint right here. Okay, no, not there. So just because, yeah, this is the function, the done function to this socket connection. So this is where we need it. Dot cache error. So when there's an error for the connection, in this case, just go ahead and console log it out. The type is gonna return is error. Let's close this off. And whenever there's an error, go ahead and log the error back to us. Maybe tell us that is unable to connect. This basically shows what the error is. Also .toString e.toString. So the reason why we are using .toString right there, I will explain that to you guys, is because, so whenever you want to log this out, when you're using the log statement is actually expecting the message to be a string. But in this case, the error is not actually a string, it's actually a dynamic, in this case an object, and the object is an error object. So what I need to do is to basically print out the toString representation of this particular object. So that's why you're using the toString on it. That will actually fix the issue, because if you don't do that, this part here will actually break and cause another error to break our code, some stuff like that. Yeah. Once we got that done, so the next stuff is actually go ahead and start implementing the data handler. So whenever there's a data coming in, we should be able to view the data right underneath here, or basically log it out. Let's go ahead and save log for now. Just log our data. So just say data. Right there, because we just want to log the data. That's why I say log data. If I go ahead and restart this, we need a way to test this. That means I have to run it on both app again to be able to test both of them. I think in that case we just need to implement this very just complete the implementation before we can actually run it on the other end. And I'm gonna copy some code that will actually help us to do that. And bring the code so in here, and then we can just talk about what we are doing and how all this stuff is working together and some stuff. So in here, after the log statements, we are going to paste the code I just copied over. Don't worry, I'll just explain this to you guys. So, yeah, there we go. So in here we have this data that we are getting out from here, from our socket, from the communication between two different users. Over here we are getting, so we are creating a variable called last element. We are saying data, which is basically the data has been returned. We are saying the data.length -1. So we want to get the last element of that data, and we want to make sure that that last element is actually something like this. Is a JSON, is actually a bracket, because each of our messages is being sent in a form of JSON, and you know JSON, they has a opening and closing brackets within it. So we are looking for this to be the end of the message. If this is the end of the message, that means we know that we could go ahead and start outputting whatever we got to the user. Else we just continue waiting for the message to complete before we can just output whatever we got to the user. So this, we need to create this variable somewhere at the top. It will just be a string, a message string, and that should be called, what's the name again we gave to it here? Image data. Okay, we'll call it image data. I'm gonna say this is gonna be a string. So string is called image data. It's going to be an empty quotes, not an empty quote, but an empty string in this case. So we have an empty string right in there. And yeah, so if this is the last end of the message, go ahead and assign it to this, and then JSON decode the whole data that's been returned. So we pass in here to decode the whole data that's been returned. And once we got the JSON format, then we can create a new variable called new message, which we can actually add to our list. If you look at our list, this is the form. Our list takes an ID, is me, a message type, and also a message right in here. Then the same stuff we are doing also right in here, an ID, which we are getting from the JSON, the ID of the user that is sending the message, and also is me. We are using the ID of the user that is sending the message to compute if the message is coming from me or if the message is coming from someone else. So that's basically what we are doing right in here. Next, we are actually checking the message type, if the message is a text or if the message is an image, because currently right now we are already able to send a text and also an image as a message. So that's why we are having these two right in there. And next stuff we actually have is message itself, the message that we receive, because this is a dynamic, so the message can be in any form. So if the message type is a text, so just pass in the message like that. But if it's an image binary, so that's how we actually explain to you guys how we actually be able to dictate if this is an image that we are sending or something else. So if it's an image, go ahead and decode the image and some stuff like that and return it back to us. So that's basically what this function is doing, and I need to get this function. So we need to create that function. That's why you're actually having the red line underneath it, basically saying that the function has not been created and we need to create it too. And here, I'll just copy the function over, and we can just go ahead and explain what this is doing. Here's the function. So basically what the function does is accept a dynamic list. Once it accepts a dynamic list, it casts that particular dynamic list to be of type a list of ints, and then convert it to a list also. So basically we have a list of ints after this cast and conversion that we're having right in here, and this int list is being converted to unsigned integer 8 list, and we are saying unsigned integer 8 list from create a new type of this from basically a list of integers, and after that just return the unsigned integer 8 list back to us for us to basically use it for whatever we want to do. So that's basically what this function is doing. Next stuff we need to do, yeah, I think that's it for this case. Since we are not sending images at the moment, we are just sending text. We could just go ahead and test this within our two phone and see if we can actually have two-way communication between two different users. So the app is running here, so let's go ahead and run it on our smaller device to make sure that the new code is actually on this particular device also, because we don't have the new code. The new changes we did right now is not within the smaller simulator that we have. So go ahead and run this. So just have to give it some time to actually finish up before we could just do what we want to do. Yeah, so right now we have the two code existing on these both users that are trying to actually communicate with each other. So let's go ahead and send some test messages across. So I'm gonna say hello, or basically hey, send, and you can actually see that this user received the message immediately, and also this user is able to see the message also on his own phone. So this is actually good, and I will reply back from here by saying it's me here, and this says it's me here, but this is not able to actually receive the message back. Okay, looks like we are having some issues. Okay, so let's try again. So send a message from here, and this user is able to receive the message that we sent. You can actually see the message console log that on our server, and also on our front end you can actually see the message console log that also right in here. So that's cool. And yeah, you can just reply back, and the reply is actually only this user is the one seeing the reply, but this user right here can't actually see the reply. So that's some issues that we need to fix. But before we fix that, let's add image processing to it, so you can be able to send images also. When you tap on this, you can be able to select images and send. We need to add that also. And we need to do that right in here. So where we are having the pick and send images, right somewhere here, somewhere over here, we have to do that somewhere here. So I'm gonna say when the user picks an image, so we are using image picker to pick an image from our app, both on Android or iOS. And once you can that's why if you tap on this, you can see this open up for us to pick an image. Also right here, if you tap over here, Yeah, this will open up for us to actually pick up an image. I'm going to close them off, and then we can just go ahead and implement the remaining code that we need right in here. But instead of writing it down, I'm just going to copy the code over, and then we can actually go ahead and explain what we are doing. So here's the code that we need right in here. Go ahead and paste. So we have an image picker right here that picks an image from our app, and once the image is being picked, we created a temporary directory for the image. So we are saying that whenever the image is being picked, we're going to create a temporary directory by using this API to create a temporary directory, and then we are going to say output path. And also the same way over here, we are creating an output path like result.png, stuff like that, to create an output path. And next, we are going to say if image is actually picked, and make sure that this is not null. If the image is actually picked, go ahead and console log the image path, and then we are going to call our steganography. I don't know if I got the pronunciation correct, but basically the library that will help us to encode some secrets into our app. So basically we are encoding a test secret into the image that we actually selected from our app, and whoever that is actually receiving that image can be able to see the secret message we added to that particular image that we sent to them. So that's basically what this is doing. But in this case, we are hard coding the secret message. It doesn't make sense to hard code it. What we could actually do is we could just go ahead and add this message dynamically from the test input field here by just saying controller, is it, or is it okay, yeah, controller.test to get access to it. But for now, I'm going to go ahead and use the hard-coded one, the dummy test for now, until we just get it to work. Then we can just change it to be dynamic. So the next stuff we need right here is we are reading the file, the image file, as a byte. So we just basically read the image data as a byte right in here, and then R creates a JSON with that byte. So basically I have ID, which is me that's sending a message, and then the message will be a byte of unsigned integer 8 list, and the type is actually an image right in here. And once we encode it, then we are going to add it to our socket as a code unit, basically a list of integers. Basically what this is doing, basically converting the JSON string of this to be in form of bytes. Basically over here they call it a list of integer, but basically it's in form of a byte. That's what this is actually doing. And once that is done, we also want to display the message to the user, that by telling the user, okay, this is the message you actually sent. They can actually see the message also right here. We are calling email messages.add the new message, so that the user that sent the image can be able to see it also. So that's basically what we are doing right there. And once that is done, I need one more function that will help us to actually help us to actually access our image once we get it from anyone that sends an image to us. So there we go. So we have this second function right here. Basically it's called get file. We are going to pass a byte. So because like I said, our socket server is going to actually return this as a byte, and our image is in the form of a byte binary, and we are going to get that like this, and then we are going to create a temporary directory for that image, and we are going to say the file path is going to image.png. I'm going to create a new file and then write to that particular file we created in this directory, or the byte that we just received that is in form of our image inside it. So that we're saying image.write as byte inside it, and we also have to wait for this to actually finish, because it's actually a fusion. We have to wait for it to finish, and once that is done, then we can actually get access to our image file to be able to display it. Let's get to the point where we want to display all the images that we're actually getting. Right in here, Yeah, you see where we are using the function get file, and we are passing a byte to it right in here, which we are getting from our message that's been sent. Next, I'm going to uncomment this section. And what this is basically doing is actually checking to see if the embedded message is not empty. Once this is not empty, so that means actually a message in there, then go ahead and show us the message in a snack bar action, basically a pop-up beneath here, which actually shows the encoded message or encrypted message within the image. Once we tap on the image, that will actually show us the encoded image, or basically the encrypted message within our image. Once we have that sorted out, so let's see what else we need to do. Our input is already done. Yeah, you can actually send images, send messages, and actually receive, which is actually working. Yeah. Yeah, I think it's time to actually go ahead and try this out and see what we just created. So let's start this right in here, and then we have to, so where did we actually started it? Okay, so we actually have to also open it up in our second simulator. So we need to close this for running, and then run this on the second simulator, which is iPhone 14 Pro Max. Right now, run without debugging. Now we have to wait for this to actually show up here. The new changes we did, we just have to wait for it to actually show up here before we can send message between both phones. Okay, once we have both of them running right now, so let's go ahead and test the stuff we just created right now and see if we have any errors or we are actually successful with what we just did. So go ahead and open this tool up, send a normal message, and you can actually see this receive the message. And also let's go ahead and send an image also to see if this is going to receive the message. And sometimes the message sending actually takes some time to actually show up. We haven't kind of like increased the speed or basically made it much faster, and yeah, it's going to take some time for us to actually see what's going on. But let's see. Yeah, so I'm seeing the message, the image I sent is showing up here for me to actually see. And over here we have to also look at this to see if we are going to receive the same message right here. Yeah, and that showed up also at this end. So I send the image from here, and we're able to receive the image on this second phone, basically on the second user right here. If you tap on the image, Now you can actually see the secret message we added, the encrypted message we added to the image. Also the same over here. If you tap on this, it's going to show us the secret message we actually encrypted also. But we just want it to be dynamic. We don't want it to be hard coded, so we can actually go over here, change that. So let's go back. So right in here where we are sending a message, we just want this to be dynamic. So I will say if controller, so if the user didn't type anything, go ahead and use this one. But if the user typed something, go ahead and use this one. But it's telling us that this will never be null. Yeah, the string is actually never null, so this will not actually go ahead and this will not be used. We need to remove this. Else what we are going to do is to say if this dot length, or basically say if it's not empty. If it's empty, go ahead and use this message. But if it's not empty, go ahead and use the typed in message user typed by themselves and send it to whoever they want to send it to. And if you go ahead and restart this again, let's try sending a message, an image. So I'm going to say this is a secret. This is a secret from me. I'm just trying to type some messages here. Okay, this is a secret from secret agent. I don't even know what I'm saying, but let's just go with the flow. So a secret agent. Okay, yeah, there you go. And we pick an image. So once that is done, you just hit the send key, or basically, okay, my keyboard is frozen. That's strange. Okay, so we received it here, the message. We received this is a secret message from agents. Also our image that we sent is doing the same. We should be able to receive the image at this end also. Yeah, we receive the test, but this is not a secret test, but everybody can see it. Yeah, but now let's see if this secret test is actually encrypted inside this image. So if you tap on the image, yeah, you can actually see this is a secret from secret agents. Also, if you tap on the image, it will tell us that this is a secret from secret agents. So that means that this test is actually inside this particular stuff we have here. So this particular image we have here, and also the same stuff is also on this image. That's why if you tap on it, you can actually tell us the encrypted message, and the same right in here. If you tap on this, it does the same too. So that's actually one way to actually use this project to send secret messages in form of images within anybody you are trying to chat with. In this case, we are not sending to one particular person, we are sending to random persons that are actually listening or using the app at the moment. We can go more further and try to implement it or fix on one or two stuff to make it able to actually only send message to whoever we want to send the message to. But in this stream, we'll not be focusing on that. But for now, we just go ahead and see if there's any other stuff we need to fix that's not working. Just minimize this, open it up again to make sure that it's actually working. Okay, that's cool. Let's see if we can actually send a message. Hopefully, we can receive it here. And that's cool. We're able to receive a message right here, but this is not trying to slide up for us to see the message that we received. Let's send again. You can actually see it. Okay, now it's sliding up here. You can actually see the two messages we send, good, hello, and also showing up here, good, hello. Now we need to reply back to the user. So I'll say, I see you. I can actually say our message is being sent to them. They can see it. I see you. And also the message actually showing up here. I see you. I can just go more further, just trying to write some stuff I don't even know about. I'm coming over. Send that message. I'm coming over. This didn't receive it at the moment, so that means the message was lost within the socket. So let's try another one. It didn't receive it also. Okay, it was able to send message. So yeah, there you go. We're able to actually talk with one another back and forth. But the thing is that we still need to add some changes, add some stuff to it, because right now it's not actually working that great. It's not that great. We need some improvement, a lot of improvement. The first improvement will be to make it not to disconnect, because at some point the socket is actually disconnecting whenever someone is sending a message. That's why we are not able to actually see some messages. Some messages have been lost along the way. So, but some of them actually we're able to deliver them. Yeah, I think that's some stuff we need to actually work on, improve it later on. But for now, I just want to show you guys how I was able to fix it, because after the last stream, everything wasn't working. We are not able to actually send messages between two phones or between two users. But after doing some research, we're able to do that. Right now, today, we're able to send messages, and we are also able to send images using socket connection, and which is actually a bit hard to achieve if you have worked with Flutter sockets. Sending images, sending audio data is not that easy. You just need do some kind of like computation along it, but I think it's much easier if you're using socket.io with Node.js, because I don't have that issue if I'm using socket.io with Node.js, and then socket.io client with Flutter is much easier. The whole messages flows along faster. But because we are implementing this on that, so we are using that for our back end, it's kind of a bit slower. Those are we need to, like I said, we just need to improve it more. But later on, I'm going to do some videos on how to actually use Node.js, sockets.io, and then use Flutter to communicate with a Node.js backend, and also build a chat messaging with different people using Node.js backend and socket.io. I think that would be much better and much fun than using that backend and stuff like that. Let's send one more message, an image. So which one should we send? So let's send this one. Yeah, hi chat. So we got a message from the chat. What's up? So yeah, like I said, one of the improvement we need to make is that this is actually slow, very slow. The image sending is actually quite slow. Actually see that, yeah, it's quite slow to display. And let's see if this is going to receive the image. It should receive the image. Let's take a look. Yeah, it received the image. That's cool. So we have the image sent from here, and this received the image that we actually sent to them. And if you tap on it, let's see any secret we encoded. I don't think we actually encoded any secret inside it. I think it's empty. Yeah, it's a dummy secret message, so nothing was actually encoded. And this, it's not actually receiving any touch events. That's strange. Okay, let's see what else we can actually do. Yeah, one issue we are having that I actually noticed is that, see, yeah, some improvement we can actually make right now. Now close this, open it up again. Then right here, if you actually go ahead and type a message and then send an image together, a message you want to kind of like encrypt inside the image, the app will kind of like will flows a bit. So let's see if we can actually fix that. So it won't flows or freeze. So I think that happens right here. So when we did pick and send and we typed in a message, so what we want to do is that once we are able to encode this right here before sending it to the server, so I'll move this right to the end, so it should be somewhere here. That's some improvement I just want to make. Before we call this, I also just want to be able to call controller dot clear whatever test we have inside our test input. Next, other stuff we also want to do is to be able to discharge our keyboard. Yeah, we can just call this hide keyboard after that. So you can actually do the same stuff here. So right now let's restart this and see if this is going to work. So over here, let's send it just a dummy test. Okay, this received our test, and it sent back a message, and we actually got the message right here. So I sent this one and I received this one. So this user received this one and this user sent this one. So right now let's encrypt a secret inside an image and send back to the user. So I'm going to say a new high level secret. And then select an image. Just pick a random image. So I'll just go ahead and pick which one? Just pick this. Okay, yeah. So this is the image you picked, the whole stuff. And this user also received it immediately, so you can actually see it's actually quite fast. In this case, looks like the small improvement we did right now actually made it to work, because it was faster than before. Unlike before, it kind of like takes few minutes to actually show up, but it didn't take that much time. So let's see. So I'm gonna tap on this to see if the message is going to show. Okay, a new high level secret here, it shows up here. Okay, that's cool. Let's tap over here and see if that's going to show up. Tap. For some reason we are not able to actually get the same effect right here. So we should be able to tap on this and see the message we sent, or the secret that's actually encoded inside this image. You should be able to see it, but for some reason it's actually showing up. We are only able to see it here, but when we tap over here we are not able to see it. So looks like we need some improvement also to see why this is happening. And if you go ahead and send another test, Yeah, so it received it also. But let's send, okay, let's try this. I'm gonna send a message from here to here. But the funny thing is that this particular app does not have the new code changes that we made, so that means I have to run the code right in here for us to actually be able to send the message from here to here. But I think it's much better right now. What do you guys think? Because actually much faster, unlike before. We're able to send and we receive it pretty fast right in there. You can actually see that. What other features you guys want to see? I think another feature you can actually add is to be able to have a way to have a user change their names and other stuff, but I don't think that's much of an improvement. Okay, the next one we are going to add is that we want the user to be able to only send a secret key that they want to, kind of like the message will be encrypted to anybody they want to send a message to, and not everyone that's listening to the server should get the same message. So I think that will be a new feature we are going to add. But I don't think it will be on this stream. So let's actually see this. Steganography. There you go. So this package has a way for us to have our own secret key. So basically our own encryption key. Okay, so basically encode the image with public key. Yeah, here. So basically generate a key pair, a secret and a public key. Over here we encode it with our public key, and then over here you decode image with a private key from key pair to retrieve the message. We do the same right in here. Yeah, so you can actually have a way for us to do that. Maybe the user can share public keys, to use public keys to decode, but in this case it needs a private key to actually be able to decode the message. So that means the users has to actually share private key within each other, which is actually a bit tricky and strange to do. So it doesn't make sense for them to share private keys. Okay, encryption key, decode same encryption key used to encode to retrieve encrypted message. Okay, yeah, I think this actually makes sense. So if we are using this particular function, then we should be able to share one particular key, which will be our public key. So we use the public key to encrypt here, and the user that's going to receive, we use the public key to decode the message. Some stuff like that, and the kind of like the key will be already be shared within both of them. So we actually have the two apps running. So let's go ahead and test it again. So I'm gonna send a message from here. Try this. Yeah, the message was received. Let's encode the secret. So I'm gonna say a new wave is coming, and then choose an image. So let's see, go and choose this one. Okay, so you can actually see the message we sent showing up, the image we sent is showing up here. So we have to wait for this also to show up, to show the message that's been received. Okay, it actually sent immediately. That was pretty fast. That's cool. Let's see if you can actually see the same message. If you tap on this, yeah, a new wave is coming. Undo. So we should be able to tap on this to actually see the secret. tap on this, a new wave is coming. So that's great. So we're able to tap over here to see the secret that has been sent, and we're able to tap over here to actually see the secret that has been sent also. That's cool. So I think one good use of this app is that it's only people that actually that uses the app will be able to see the secret message that you guys are sending within each other, except we are going to change our implementation to basically make use of this particular one here, whereby you can actually share a public key with each other. So in that case, it will only be between you and the person you are trying to send a message to. And I think another way to do that, because there's no way to know which user you're trying to receive the message from. So maybe we should have a hard-coded kind of like identifier that you can share with each other. So when you send a message for the first time, the server will be able to look within the two. So if we open up our server, so our server can actually take that. I don't think it will be that hard to implement. Maybe I'll check it out, and then our next stream we're going to see if that is going to work. So over here, so let's see. Okay, this part that's actually broadcasting our messages on this part. So let's say we want to actually send a message between two clients that actually has the same public key, I guess. So if the public keys are matching, so send a message between those two clients. So I think that makes sense in a good way. So let's say this user is going to have a public key, my public key, and this user is going to have my own public key. So when we send a message between each other, so that message will only be delivered to both of us and no longer any other person that's actually listening to the server that will actually receive it. And we just need to add that right here. So that will be our chat client should have a variable that contains the public key or some stuff like that. Yeah, public key. Yeah. And then once we are looping to see who we are going to send the message to, we are going to look to see which of these two clients is actually having the same public key as our clients that is sending that message. But we're going to write that particular message to only that client alone. That's one way to actually fix this. And then we'll be able to have a real secret messaging app, and not just a worldwide kind of like an open secret messaging app that everybody can listen to secrets that's been sent by everyone. But in this case, you just only listen to secrets that's been sent between you and the person that's actually sending it. So you need to know the person for you guys to share a public key within each other. Yeah. So let's see. And we just need to on the UI we just need to add some kind of a feature whereby you can actually see a way to generate new public keys or generate new keys to share with each other before you can actually be able to send messages with the person, and the person can actually receive the message that you actually sent. Yeah, I think we are going to add those ones tomorrow. So guys, join me tomorrow. We're going to look into that and see if that is possible to actually create. And if we're able to achieve that tomorrow, I think that would actually be great. And maybe we just try telling people to use the app. I'm just joking. But if we achieve that, most of you guys can actually try it out and see if it's working, and nobody will be listening to your secret that you are sending with anybody. Yeah. Okay guys, thank you guys for joining. If this is your first time, please do subscribe to the channel wherever you're watching from, both from Twitch, YouTube. Let me know what you guys think about what we just did, if it's actually useful to you guys, and if you like the stream or you learned something from me, just let me know on the comment section, basically on the YouTube comment section. And you can also actually reach me out on my other social media pages on Instagram, Twitter, and so many other places. I'll be there waiting for you guys' messages. With that being said, Thank you all for joining, and have a nice day, everyone. See you guys tomorrow. Yeah, I will actually stream tomorrow. I will not forget tomorrow. So just guys, jump back tomorrow, and we could just continue for where we stopped.